Okay, so welcome back, and now in this video we're going to do we're going to do a lot of examples here. They'll be very simple. All we're going to do is identify which functions represent exponential functions. That's it. So by definition, all you have to do is look at the base, right? It has to have a base that's a constant, and it has to have a variable exponent. That's it. If it violates either one of those, you do not have an exponential function. So let's go through these real quickly. So, does A represent an exponential function here? The answer is yes, because we got a constant as a base, and we've got a variable exponent, right? There's x in the exponent, so it's variable. So this is an exponential function. So that's good. Now what about B? B is not an exponential function because it violates the definition of an exponential function. So it does not have a constant base, does not have an exponential, or excuse me, a variable exponent. So, no. Okay, what about C? C, yes. C is an exponential function. It's got a constant base, variable exponent. What about D? Yes. D is yes. Because again, we've got a constant base, variable exponent. So good. Now what about E? Well, E is not an exponential function. In fact, it's a quadratic. Oh, by the way, this is a power function or a cubic function. This is also a power function, but it's a polynomial function or a cubic function. Actually, I think I wrote this down wrong. This, I believe, is squared. It's quadratic. So no, that is not an exponential function. Now what about F? Yes, it is. Even though it's a decimal, that's fine. It's okay. The base can be any real number other than 1. Any positive real number other than 1. So this is good. Okay, so that is an exponential function. Now what about G? G is what? G is not an exponential function. Again, it does not have a constant base with a variable exponent. This is a linear function, right? So this is a no. Now what about H? H is an exponential function. Okay, and there you have it. Have a great day.